Alright, so review video number 1. This is first period. 1, 4, 7, 10, ... Look for the other videos if you want the other solutions. Alright, number 1. Let f of x equal 2x plus 1 over x. What values of c are guaranteed by the mean value theorem? Mean value theorem. Calc slope equals algebra slope. And calc slope at a certain point equals algebra slope over the whole thing. So what value of c, that means where does it work, that the calculus slope is equal to the algebra slope. So job 1 would be to find the algebra slope. y2 minus y1 over x2 minus x1. So got a little bit of an algebra problem here. So y of 1 would be 2 plus 1 over 1, that would be 3. Y of negative 1/2, that's kind of annoying, but maybe it'll work out. 2 times negative 1/2 is negative 1. 1 over negative 1/2 would be negative 2. Yeah, just flip the 1/2 and get negative 2. So we get negative 3. So 3 minus negative 3 over 1 minus negative 1/2. So what is that? 6 over 3/2, which would be 6 divided by 1.5, or 6 times 2/3. However you want to get there, that'd be 4. So my algebra slope is 4. Now I need to take the calculus slope and set it equal to 4. And I'm guaranteed to get, oh, wait a minute. I'm looking at my answer choice here. Why would, what should I have checked first? Like, what has to be true for MVT to work? 2 conditions. Continuous and differentiable on this interval. Is this thing continuous between negative 1/2 and 1? What's the problem? Can't divide by 0, so at x equals 0, it's not continuous. So I spun my wheels a little bit. Probably should have read the answers first, and then that's what caught my attention, was when that option was there. I was like, wait a minute, I better make sure this is even possible. My guess is if you do the problem, you might get an answer, but it's not guaranteed by the MVT because this is not continuous. So, shame on me for not checking first, but again, that's why you check all the answer choices or try to reason through why is that there. It's because there are times when MVT isn't guaranteed, and it's when it's not continuous or differentiable. Number 2, I'm going to save and do later, but it's kind of the same question, but the interval is good. There's not any problems with 1/2 to 1, so I can throw out D. Zeros, in fact, I didn't mean to do number 2, but what values, they've got to be on this interval. 0 is not on that interval. Negative is not on that interval. So, yeah, you hope you get one that easy. I didn't even have to do the problem. I could rule out all the bad answer choices and get B. Number 4. How many critical numbers, that would be where f prime equals 0 or f prime undefined, does G have if G is that big? Okay, well, this looks like quotient rule here. So derivative of the top is 2x Derivative of the bottom is 2x. Quotient rule is gf prime. Gf prime minus fg prime. Clean that up. Over the bottom squared. So let's see. 2x cubed minus 8x minus 2x cubed minus 8x. So the top becomes negative 16x. The bottom is x squared minus 4 squared. 16x. So f prime is 0 or undefined. Well, it would be 0 when the top is 0. It's undefined when the bottom is 0. So the top is 0 when x is 0. And the bottom would be 0 when x is 2 or negative 2. X squared minus 4 equals 0. So x equals plus or minus 2. So there's my 3 critical numbers, where f prime is 0 or undefined. And then I had to do the f prime and then know that 0 would, when the top is 0, it's undefined when the bottom is 0. These problems just continue to build on themselves. And all the previous skills, you've got to still know. Number 7, consider this function. Find the critical numbers. Okay, we just did that. So that would be where h prime is 0 or undefined. And since there's a denominator, I'm guessing there's going to be some undefined issues in there. Justify your answer. Oh, well, I just did that already. There's my justify. Give me some partial credit just off of that. Relative minimum. So I'll need to know where h prime changes from, let's see, negative to positive. Relative max. H prime changes positive to negative. In fact, I could do all these justifies right now. H prime changes negative to positive. That would give me a relative minimum. A relative maximum would be where H prime changes positive to negative. H is increasing where H prime is positive. Concave down, that would be where H double prime is negative. Point of inflection would be where H double prime changes signs. That's probably not half the points, but that's probably a third of the points of that, because I just justified all my things before I even got started. So that means even if you mess up taking a derivative somewhere, you mess up a sign or you forget something, mess up the quotient rule, like, you're still going to get a big chunk of the problems right, or of the points right, if you justified correctly. Alright, so let's back up and actually take the derivative of this thing. So the top derivative is 2x minus 4. Bottom derivative is just 1, so that's kind of nice. So gf prime would be x times 2x minus 4 minus the other way, x squared minus 4x plus 1 all over x squared. Clean that up a little bit. 2x squared minus 4x minus x squared plus 4x minus 1. Is the top. So 2x squared minus x squared is x squared. Negative 4x plus 4x goes away. And then minus 1. and then bottom x squared. So that was kind of an ugly original, but the derivative sort of rigged to be not so bad. So top equals 0 when x is plus or minus 1. Bottom is 0 when x equals 0. So there's my critical numbers. Plus and minus 1 make the derivative 0. 0 makes the derivative undefined, so that's a critical number as well. Okay, I'll need to do a sign chart to figure out where it actually changes, where h prime changes. So negative 1, 0, 1. Let's see. Yes. Oh, 0 is a double root, so I better be careful about that one. It's not going to alternate if I'm thinking about the alternating rule. Let's plug in 2, just because that should be the easiest one to plug in. Plug in 2. 2 squared minus 1 is 3. 2 squared is 4. Everything's positive, so f prime is positive. If I plug in 1/2, that's kind of ugly, but I don't care about the exact value. I just care about getting the sign right. Half squared is a fourth. Minus 1 is negative. Over half squared is positive, so that's negative. And then I'm going to trust my alternating rule. It's not going to alternate across 0. Which means if you want to check negative 1/2 or you want to check negative 2, you can. But I think we're good. Okay, so relative minimum is when h prime changes negative to positive. So that means there's a relative min at, so I'm going from negative to positive. That would be at x equals 1. And we've already got the picture for part C. H prime changes positive to negative at negative 1. So there's a relative maximum at negative 1. On what intervals is h increasing? Well, h prime is positive from negative infinity to negative 1 and 1 to infinity. Alright, concave down, I need a second derivative. So I get to do the quotient rule again. The derivative of the top is 2x, the derivative of the bottom is 2x. So gf prime 2x cubed minus 2x times x squared minus 1. So that's going to end up being just 2x after I distribute the negative and collect like terms, all over the denominator squared, x to the 4th. So let's see. I could reduce that and get 2 over x cubed. That's my second derivative. Well, it's not a critical point. That's the first derivative thing. But the critical point, again, somebody needs to invent a word for this. But the point of concern for the second derivative would be where the bottom or top is 0. So x equals 0 makes the bottom 0. And then I can check my second derivative. This is pretty easy. The second derivative is a lot simpler than the first derivative. If I plug in a positive, I get a positive. If I plug in a negative, I get a negative. And so we're concave down from negative infinity to 0. Okay, point F, or question F. At what point, so I need to give a point, does the graph of H have a point of inflection? So where does H double prime change signs? At 0. But it asks me for a point, so I don't want to just say at x equals 0. I want 0 comma something because it asks me for a point. At what point? So how do I figure out the y coordinate? Plug it in, but plug it into what? Now I've got H double prime and H prime and H. Where's that 0 going? In the original, in the first derivative, or in the second derivative? In the original. So if I plug it into the original, H of 0, 0 squared minus 4 times 0 plus 1 all over 0. Uh-oh. I can't divide by 0. So there is no point of inflection. Because there is no graph at 0. So it changes signs, but, I mean, concavity changes, but there's not a point there because there's an asymptote there. I have no idea what this graph looks like, but what that might mean is something like that. That's concave up, that's concave down, but there's not a point of inflection there because there's not a point there. So if you read the directions carefully, you'll figure that out along the way. Alright, that was a long one, but that covered a whole bunch of stuff. Number 10. If G is this thing, then at x equals 1, which of the following is true? G prime is increasing or decreasing? That would be a first derivative thing. Relative max, relative min, that would also be a first derivative thing. So let's do a first derivative and see what's going on at x equals 1. Okay, product rule. So I'm going to do first times derivative of the second plus second times derivative of the first. At x equals 1. Kind of don't like this problem, but so G prime at 1, let's just see what we get, would be cosine of 1 times 1 plus sine of 1. Like, well, what is that sine and cosine of 1? Let's see. Pi is 3.14. So pi over 2 is 1.57-ish. So that means 1 is, I don't know, somewhere in the first quadrant, which is all I need to know. Because cosine in the first quadrant is positive, sine in the first quadrant is positive. If G prime is positive, then G is increasing. I bet there's a bunch of people who will miss that because they don't understand how to find the cosine of 1 because it just feels weird. But they made it an easy enough number that you can figure out at least what quadrant it's in. Alright, Ian, on to the one you asked earlier. Number 13. Absolute minimum, that is sort of a red flag to check the endpoints. On an interval, that's kind of a red flag to check the endpoints as well. So let's do a derivative to find the critical points, but then we also need to check our endpoints. So I'm setting up my table. I'll plug those into f of x, and then I'll just pick the almost said highest one, but for minimum I'll pick the lowest one. Right, f prime 3x squared minus 3x. So I can factor out an x. That leaves x minus 1. So x equals 0 and x equals 1 are the critical points. Both of those are in the interval, so I can check both of them. Remember, occasionally you get a critical point that's not in the interval. At that point, you can just throw it out because it's not in the interval. You're not worried about it. All right, plug in -1. I get 1. Oops, I get -1 minus 3 halves. That would be -5 halves. If I plug in 0, I get 0. If I plug in 1, I get 1 minus 3 halves, which is -1 half. And if I plug in 2, I get 8 minus 3 halves times 4. That would be 6. 8 minus 6 is 2. And so my smallest number is -5 halves. Let's be careful about the answer. What is the minimum? The minimum is -5 halves. It occurs at -1, but that's not what the question asked. So the smallest value on that interval is -5 halves. And that's one I think I mentioned earlier. If you didn't check the endpoints, you might pick -1 half. People don't check endpoints. Check the endpoints. We're not doing 14, but it's kind of the same thing. Make sure you check the endpoints. Number 16. Looking through these, this is very similar to the test in some areas, so make sure you understand all of these questions. Number 16. At what value of x does x e to the x attain its maximum value? Explain your answer. Okay, let's do a first derivative. First times derivative of the second. Whoops, I said that. I did the derivative of the first times the second plus the first times derivative of the second. I don't know that I said all that right, but that's right. One of them times the derivative of the other plus the other way around. Let's factor out e to the -x. That leaves 1 minus x. So critical points would only be x equals 1. So let's see what happens at x equals 1. If I plug in 0 to f prime, because I want to know increasing, decreasing, probably plug it into that one. I get e to the 0 times 1 minus 0. E to the 0 is positive, 1 minus 0 is positive. If I plug in 2, I bet I get a negative because of the alternating rule. E to the -2, that looks funny, but remember that's just 1 over e squared, so it's positive, times -1, so yes, that's negative. Okay, so that means we're increasing all the way to 1 and we're decreasing after that. So this thing has a max at what value of x? has a max at x equals 1, because f prime changes from positive to negative. And it's the only place where that change happens, so I know like that's the only possible max there is. There aren't any other maxes to worry about. On what intervals is g decreasing? That would be where g prime is negative. So I look at my graph of g prime. Again, please be careful. That's the graph of g prime. A whole bunch of people are going to say, oh, g is decreasing from there to there. Like, no, that's g prime is decreasing. G prime is negative right there. Again, you have to really be careful and train or trick your brain to know what to look for. Thank you. So that would be from -4 to 7. The graph of g is decreasing.
Isn't it just from 4?
Whoops, sorry. Yeah, I don't know why I said -4. -4 is not even on the graph. From 4 to 7. Number 22. What is g double prime at 1? So g double prime at 1. Here's 1. G prime at 1 is 2, but that's not what it's asking. How am I going to answer this question? I don't have a graph of g double prime. G double prime is the slope of g prime. So the slope of g prime at 1, slope of g prime at 1 is 0. So understanding that g double prime is the slope of g prime, or whether you could no, that's how you said it earlier, whether g prime is increasing or decreasing. So that's a concept question with almost no calculation, but you definitely have to understand that what derivative means. 25, that's a good pairing with 22, because the concavity of the graph of g means I want to know where g double prime is positive, but that's the same thing as where g prime is increasing. So g prime is increasing from 6 to 8, would mean g is concave up, because I'm looking at the slope of g prime, because the slope of g prime is g double prime is concavity. Same thing on the negative side. If g double prime is negative, that means g prime is decreasing. Probably shouldn't put equals there. I should probably just be like colon. That happens from 2 to 6, where g is concave down. Again, those questions should go quick, because you're not taking a derivative. There's no quotient rule. There's no sines and cosines. It's just looking at a picture and making sure you know what you're looking at. (28). Oh, there's one like 28 on the test. It's not worded like this, but it's that same idea. At which of the points on the graph are dy dx and the second derivative both negative? Well, dy dx is the slope, and the second derivative is the concavity. So I want slope to be negative, and I want to be concave down. So which of those points are concave down and negative slope? What's that? B. Concave down with negative slope. Another one of those concept questions, no calculations needed. 31. We're going to be able to finish before the bell rings, just barely. The graph of f is shown on the right. Oh, okay, so careful with the brain here. That's f, that's not f prime. This is f. Which of the following could be the graph of f prime? So I'm looking at potential f prime candidates here. Let's see. So f prime is the slope of f. So right there the slope is 0. So that would be one thing to look for. I want the slope to be 0 right about there, so C works. D does not. B does not. And A works. Alright, so now I need another something to look at. What's the slope right there? If my graph is decreasing, f prime is negative. So I need from wherever that point is over to have a negative f prime. So that works for A, but that's not right for C. So my answer is A. That's another one that's strictly a concept thing. You got to understand what f prime means. F prime is the slope of f. And then piece it together. 34, the derivative attains its maximum value. Okay, well let's find its derivative first, and then we'll worry about the maximum value. So that would be 4x cubed over 3 minus x to the 4th. But that's the derivative of f. So I want the max value of that thing. So if I want to find that thing's max value, I need to take its derivative and set it equal to 0. You understand why we're going to take another derivative? Because I want the maximum of a derivative. So here's the derivative. Let's just, maybe it's easier to say, let's just call this g. So there's g. If I want the maximum of that, then I need to take a derivative, put it on the number line, test the increasing, decreasing intervals. But this one's worded weird that I got to take a second derivative. 4x squared minus 4x cubed. Help us out here. So x equals 0 and x equals 1 are our critical points. I think I can answer this already, because 0 is a double root, so that's not going to be a max or a min. So he's out. My only other option is 1, so I'm guessing the answer is C. Now, officially, I should probably plug in 1/2 and 2 to make sure that that's a maximum. So if I plug in 1/2, let's see, that would be positive. 1 minus 1/2 would be positive. I plug in 2, 1 minus 2 is negative, so that means f is going from increasing to decreasing. So yeah, there's a maximum at 1. That's an old AP test question, where it asks you to maximize the derivative, and so you've got to really be paying attention. Take a derivative, and then maximize that, so take another derivative. Okay, stay tuned for all the other videos that'll have all the other answers on them.